Okay, this is the genset room. Now we're going to routine test the genset, but this genset are currently having some problem, not able to run, so we're going to have a general checking. Okay, first of all, we're going to check the battery. Make sure the termination is tightened. Battery water okay. So we're going to see the battery water level. All is at high level. Okay. Then check for any leakages of fuel. Okay, belting will be under repair sooner or later. Okay. No leakage. Starter cable connection is firm. Okay. Earthing, neutral earth and earthing termination good. Then we're going to check the engine oil. Okay, engine oil okay, clean. Engine oil level correct. Then we check the battery voltage. $26.9. About 27.
Is it normal?
Yeah, normal. Best not to go higher than 28.
Okay.
Because all these starter, relay or everything is rated at 24 volt DC. If you go higher than that, the thing can be spoiled, or it will overspeed the genset during starting mode. So in between 27 and 28 is the best range before start of genset. So actually this voltage is acquired from the charger. This is the charger. Here, you can set the charging voltage from here by fine-tuning this adjustable rheostat, we call it variable resistor. Okay, so currently we are not going to test it, but we're going to have a routine check. Okay, and then we need to check the radiator water level. So here I need to climb up. Okay. Radiator water level. Okay. There's coolant. Okay, green color. Okay. Let's go down back. Okay. Fuel filter. Okay. CO2 system. Okay. Okay, now we go to the LV. Okay, this is the LV room. Currently, now we are at the LV room. Let us check the voltage for transformer 1. This is MSB 1. Okay, frequency. Maximum 600 amp.
So it's normal, no?
Yeah, it's normal. It's quite low.
No usage.
Average low side is 233, high side is 252, still below 253 volt on the single phase, so shouldn't be any problem. This is MSE1 coupler, and then we have the incoming. This is incomer 2 from transformer number 2. This is a 3-phase, this is average, this is on the high side. A little bit higher on the high side. This is a voltage 253, slightly a little bit higher, 253. Some cases I see before about 260 volt.
So what is the normal one?
Normal on under average about 240.
Oh.
240 if let's say at normal rate like now, if it goes like 250, then it's on the high side. You need to adjust your transformer tap.
Oh, okay.
Okay.
So you need to do calibration, am I right?
During servicing time, adjust the transformer tap using tap 1 or 2 to lower down the voltage ratio. Okay, this one is a power factor. Currently it's at unity, no problem. Okay, on the MSB one also at 1, no problem. This is the essential switchboard. Essential switchboard, and this is for the MSB M, that means common area. Let's have a look at common area. What are the consumption? A little bit higher on the maximum side. Currently it's 245. This is a volt. M is just 46. The 1916M is recorded during previous time. Previous time, that means I don't know how many months already, during when they test everything, during the commissioning time. That's why everything run, it is recorded 1916. When they run all the firefighting equipment, all the fan, during, I think most probably is during the bomba testing. It's recorded this on the high side. We are not able to test the genset, otherwise I'm going to show you how to jump the signal from here.
Oh, okay.
That one is for the consumption of the whole management common area. This one is only on the essential side. That is non-essential. This is essential. The label is red color. So from here you can see also quite low, 28 M only. I think the lift also not operating, right?
Yeah.
Maybe no people.
Yeah.
Okay, come now we go to the HV room and transformer room. Okay, I'm now at the transformer room. This is a Tennant transformer, and this is a Tennant transformer also. This is a common area transformer. First of all, we must make sure the room ventilation is in good condition. Currently it's running, there are ventilation. So we have to check the temperature. This is a common area transformer. It's for the owner side. Okay, from here, we can run the air force fan. Okay, now the fan is running. But here, originally, okay, there's fan installed. Yeah, so it's running. Okay, then we can off it manually. A is the yellow phase, A is a red phase, B is a yellow phase, and C is a blue phase. So normally we take the yellow phase as a reference because it's located at the middle of the core. It's the most warm, most highest. Because the transformer is 1, 2, 3. The center core is the most warm one. So we will take the center one, the temperature at the center as a reference for the overall transformer. So if they say, how I know this transformer is performing, is it hot or not hot? By referring to P. Referring to P. A is red phase, B is yellow phase, 62.1 is the highest. C is a bit low because it's at the side. So we take the center core temperature as reference. So for task visit transformer, if let's say the temperature is below the alarm setting point and also the heat wave, no problem. This one can go until 150 degrees Celsius. Above that only it change. And under the thing we already give an alarm. But now it's just 62 only, right? So no need to worry, no problem. Okay, now we look at the Tennant transformer. This is a Tennant transformer. A is a read phase. 60 only. Because due to no load, so the temperature is very low. So there's another one. 57.6. This is for the temperature of...
No, I mean this is standard.
Tennant MSB1, MSB2. That one is common area, smaller one. So there's an air force fan installed inside the transformer. Once it reaches certain level of degrees Celsius, the air force fan will operate. It will force the air inside and cool down the transformer. There's a setting. The setting is set from here. That setting is most probably 90. When it reaches above 90, the air force fan will operate. Will operate until the temperature cool down, drop below 80 degrees Celsius. But that range can be sectable. Some they use 70, some they use 60. It's programmable from here. Okay, everything in good condition. So now we go to the HV room. Okay, now we check the CO2 panel, no battery fail, everything in good condition. Okay, so we go in HV room. So that is a CO2 panel indicator light. Okay, this is a HV room. First of all, we need to check the tripping unit. Okay, we have two tripping units here. One is for the Tennant switchgear, another one is for the management switchgear. The voltage is above 30 volt. Above 30 volt, the charger is operating. Let's check the battery. Okay. Termination all okay. Battery water sufficient. No overcharging. How to know the battery is overcharging or not? Put your hand here. If you feel it's warmer than the room temperature, that means you feel a bit warm. But like this is okay, same as the room temperature. If it's warmer than that, definitely there's some overcharge. But it depends. Some is too excessive overcharge, some is a little bit slightly overcharged. So if it's too excessive overcharge, you need to fine tune the charger here. But this one is okay. So after we check the battery, this room doesn't require any ventilation at this moment because it's not hot. So it's okay if it's not running. Okay, let us see the CO2 panel and then the CO2 system. Pressure is okay. It doesn't discharge and it's not empty. There's an echo sound there. So it's not empty. Okay. Okay, let us check transformer number 1. No load currently. This is voltage rating. Okay, this is incomer number 2. Around 2 amp, 3 amp. Load quite low. Transformer number 2. Amp also quite low. This is management side. 2 switch gear. One is incomer and another one is feeder to the transformer. 1 amp only. 1 amp only, quite low. For this, you can check whether the heater is healthy or not by pressing here. This light indicates the temperature thermostat is in good condition and there's a relay controlling it. If let's say it light, it means there's 240 volt going to the heater. But there might be possibility that the heater is faulty. This only indicates the control is in good condition. Another way is you can check the heater by using the clamp meter to check how many amp at the heater to truly confirm whether the heater is in good condition or not. If it's in good condition, there will be current reading. Okay, how we know? You see, this is a heater switch. Okay, so there will be current here. As we use a clamp meter, put it there, it will show a reading. See, 0.19. That means the heater is in good condition. Most probably, if let's say your switchgear is more than 10 years, then mostly the heater will damage or faulty. But if let's say this building is just within a few years, seldom the heater spoil. Another way to check it, if let's say this is the switchgear and you know the location where the heater is installed, you can feel it here. Here they got two. One is here. You see here is warm. Correct. This is the location of the heater. And another one is here. Somewhere around here. But this one a bit center. But on the center of the panel, you can't feel it because you cannot touch that area. So you must use other method. But if some site, they only got one or two switchgear, then you can check the heater by feeling the heat. It's actually more accurate because you know it's warm, right? Another way, if let's say you have a thermal scan, you can sense the different temperature here. Okay, so everything is in good condition. And okay.